Okay, for question number 34, part A, we have to find the coordinates of the foot of the perpendicular drawn from the point 2, 3, -8 to this line. Equation of the line is given in the Cartesian form. So let's visualize this problem first. Let's say this is the perpendicular drawn from the point 238, and this is the given line with the given equation, and this line is drawn from the coordinates 2, 3, and -8 to the line. This is 4 minus x by 2 is equal to y by 6 is equal to y minus z by 3. Now let's get this in the standard form. To get this equation in the standard form, or yes, let's get this in the standard form, because the standard equation of the line in Cartesian form is x minus x1 by a is equal to y minus y1 by b is equal to z minus z1 by c. So if we take negative out here, so this is x minus 4 by -2, it's equal to this is y by 6, this is z minus 1 by -3. So now this is the standard equation of the line. Okay, now let's say this is equal to lambda. So let's equate this all these to lambda and get the values of x, y, and z. So x minus 4 by 2 is equal to lambda gives x is equal to, this is 4 minus 2 lambda. And similarly, if I equate this to lambda, which gives me y is equal to 6 lambda. If I equate this to lambda, which gives me z is equal to 1 minus 3 lambda. So we have the values of z, y, and x. And let's say for some value of z, for some value of lambda, this be the foot of coordinates of the foot of the perpendicular. So coordinates of the foot of the perpendicular be, let's say 4 minus 2 lambda for some value of lambda. And this is 6 lambda, this is 1 minus 3 lambda. So 4 minus 2 lambda and 6 lambda and 1 minus 3 lambda. Now, okay. So we have got the coordinates of the foot of the perpendicular for some value of lambda. Now let's say this is line AB. So what would be the direction ratios, or the direction ratios of line AB? So I'm going to write down the direction ratios of line AB, which are given by x2 minus x1, comma y2 minus y1, and z2 minus z1. If we know the coordinates, so this is x1, this is let's say x2 and x1. So 4 minus 2 lambda minus 2. So x2 minus x1. 4 minus 2 lambda minus 2. So this is, let's say, x2, x1, x2, y2, z2, and x1, y1, z1. So 4 minus 2 lambda minus 2 will give me 2 minus 2 lambda. So this is 2 minus 2 lambda. Similarly, 6 lambda minus 3. So 6 lambda minus 3, and z2 is 1 minus 3 lambda. Minus of minus 8 is 1 minus 3 lambda plus 8, which is 9 minus 3 lambda. So this is 9 minus 3 lambda. So these are the direction ratios of AB. Okay, similarly, let's write down the direction ratios of line. Let's say this is line C, or this is, let's say, line L, and its equation is given to us. So its direction ratios are here. The direction ratios of line L, these are -2, 6, -2, 6, and -3. Now AB is perpendicular to L, so that means A1 into A2 plus B1 into B2 plus C1 into C2 is equal to 0, where these are the direction ratios A1, B1, C1, and these are the direction ratios A2, B2, and C2. So let's multiply them. So 2 minus 2 lambda into -2 is -4 plus 4 lambda. B1 into B2, 6 R is 36 lambda minus 18 plus -3 into uh, 9 is -27 plus 9 lambda is equal to 0. Okay, so this is 36 lambda plus 9 is 9, 6, 36 plus 36, 4 plus 36 is 40 plus 9 is 49 lambda, and negative 4, negative 18 is negative 22, negative 32, and negative 27 is negative 49, which is equal to 0. So which gives me 49 lambda is equal to 49 and lambda is equal to 1. So we have got lambda, and let's write down the coordinates of the foot of the perpendicular. So coordinates of foot of perpendicular are coordinates of foot of perpendicular are. Let's put in the value of lambda here, which were 4 minus 2 lambda. So which were these were 4 minus 2 lambda common, comma, and 6 lambda, and was 1 minus 3 lambda. Okay, let's put in the value of lambda here, which is 1, 4 minus 2, 6, and 1 minus 3, which gives me 2, 6, and negative 2. So 2, 6, and negative 2 are the coordinates of the foot of the perpendicular. Now we have to find the perpendicular distance as well. So we have got the coordinates and we can use the distance formula. So coordinates of B are 2, 6, negative 2. So here the coordinates are 2, 6, and negative 2. And we have to find the perpendicular distance from the given point. So perpendicular distance from the given point can be, you can find that using the distance formula. So this is 2 minus 2 is 0 square plus 3 minus 6 is negative 3 square plus negative 8 minus of minus 2 is negative 6 square under root using the distance formula. So this is 9 plus 36, which is 45, and I can write 45 as 9 into 5. So this is 3 root 5 units is the perpendicular distance.